Hello students, welcome to my class on computer graphics. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. In my previous class, I already discussed the different types of 2D transformation and their derivation. Now, in this class, I will show you the different numerical examples. That means how those different transformation can be applied on some real life problem. Okay. So you can see the first problem is based on the translation. So here the problem is like that. There is a point whose coordinate is 2, 6. Now we have to translate the points 4 unit in x direction and minus 3 unit in y direction. Fine. So as you know that, so first let me draw the position of the points. So consider this is the coordinate system and this is y-axis, x-axis, this is origin, and the coordinate is 2 unit in x direction and 6 units in y direction. So let us say this is 1, 2, 3, 4, 5, 6. And similarly, this is 1, 2, 3, 4, 5, 6. Fine. So let it this is 6. So what is the position of the point 2, 6? So 2 units. So this is 1, this is 2, and here this is 6. Fine. So the position of the point P is somewhere here. Okay. So this is the position of the point P with the coordinate 2, 6. Now we have to translate the point 4 unit in the x direction and minus 3 unit in the y direction. And you know that the translation matrix T is nothing but 1, 0, Tx, 0, 1, Ty, and 0, 0, 1. Okay. So where Tx and Ty is the translation factor, translation amount. That means how many unit I have to translate the points in the along x direction and how much I have to translate along y direction. So here you can see that the translation unit along x direction is 4. So Tx we can write 4, and here it is given that Ty is minus 3. Fine. So we will write it Ty minus 3. Clear? So what we will do now? We will substitute this amount Tx and Ty in this matrix. So our translation matrix will be 1, 0, minus 4, 0, 1, minus 3, and 0, 0, 1. Okay. Now, what is the point vector? The point matrix is 2, 6, 1. And we assume that the translated point matrix P dashed will be x, y, and 1. So this x, y, 1 is the translated point. We don't know. And as per our discussion, you know that we can get P dashed by using the equation T dot P. That means by multiplying the translation matrix with the point matrix. So if we do so, what will happen? We will write like that. So our P dashed is equals to 1, 0, minus 4, 0, 1, minus 3, 0, 0, 1, and then 2, 6, 1. Fine. Now if you multiplied it, if you perform the matrix multiplication, you can see sorry, this unit is not -4, this is 4, so we make it +4. It is +4 unit as it is given. So if you now perform the matrix multiplication, you can see that the answer will be 1 into 2, 0 into 6, 4 into 1, fine. So it will be something like that, 2 plus 0 plus 4. For the next one, it will be 0 plus 6 minus 3, and the last one will be 1. Okay. So after doing the matrix multiplication, the answer we will get 6, 3, 1. So this is our translated coordinate of the translated point. So that means this 6, 3, 1 is nothing but the x, y, and 1. So before translation, the position of the point P was at this location. Now after translation, the new coordinate will be 6, 3, 1. Okay. So it will be 6. That means 6 unit along x direction. So this is 6 and 3. So this is our 3. So somewhere here. Okay. So this will be the translated point with coordinate 6, 3. Clear? So in this way, you can perform the translation of a point. Now, in the next problem, you can see that we want to perform the translation. We want to perform the translation for a square with the coordinate 0, 0, 0, 3, 3, 3, and 3, 0. And the translation amount is 2 units in both directions. So the same thing we have to perform as I discussed in the last problem. So what I have to do? Here again I am writing the translation matrix T is nothing but 1, 0, and what is the translation amount? 2 in both directions. That means the translation matrix is 1, 0 tx, 0, 1 ty, and 0, 0, 1. Okay. And here you know that tx is 2 unit and ty is also 2 unit. So if we substitute this tx and ty, the final translation matrix will be like that: 1, 0, 2, 0, 1, 2, and then 0, 0, 1. Okay. Now our point matrix P is nothing but, so this is a set of points. What are the points? 0, 0. So we can write 0, 0, 1. This is the coordinate of the first point. The next one is 0, 3, 1. Next one is 3, 3, 1. And the last one is 3, 0, 1. Now if I want to perform the translation of the square, so what we have to do? We have to find out the new set. After translation, we have to find out the new set of points for that same square. So for the same square, the new set of points, let us say it is P dashed. Okay. So what is our P dashed? P dashed will be nothing but x1, y1, 1, x2, y2, 1, x3, y3, 1, and x4, y4, 1. Okay. Now, what we have to do, how we can get P dashed? And you know, we can get P dashed just by multiplying T into P. So if you do so, what you will get? You will write down, you will substitute T. T is my this one, 0, 0, 1. And what is P? P is 0, 0, 1, 0, 3, 1, 3, 3, 1, and 3, 0, 1. Now, if you perform the multiplication, you can get the, what will be the first value? It will be 1, 0, 2. So the first one will be So after performing the matrix multiplication, the first value will be 2. The second value, what will be the second value? It will also be 2. The third one is a 5, and the fourth one is also 5. Okay. Now, here again you multiply the second row, that means this one, with everyone. So we will get the value of second one. So it will be 0, 0 into 2. So it will be just 2. Now next one is 0 into 0, 1 into 3, 2 into 1. So it will be 5. And the next one is same, 3 into 1 and 2 into 1, and this will be multiplied by 0. So it will be again 5. And the last one will be 0 will be multiplied by 3, 1 is 0 and 2 will be 1. So it will be 2. And now if you multiply the last one, the last row will remain 1, 1, 1. So that means my translated point are that the point of the square after translation is 2, 2, then 2, 5, then 5, 5, and then 5, 2. Okay. So if we draw our axis, then you can see consider this is 1, 2, 3, 4, 5, and 6, and this is again 1, 2, 3, 4, 5. So what is our initial point? The initial point was 0, 0. So that means that origin. So this is 0, 0. Next one is a 0, 3. So this is our 1, 2, 3, 4, 5, 6. Let us mark it 1, 2, 3, 4, 5. So the 0, 0 is the first one point. Another point is 0, 3. That means the value of x is 0, and this is a second point. Okay. Next one is 3, 3. 3, 3 is somewhere here, and 3, 0. So actually the square will be, before translation, the square is like this one. So this is our square. Now after translation, the point is now become 2, 2. So 2, 2 is somewhere over here. Then 2, 5. So the along x direction it is 2, along y direction it is 5. Somewhere this one, 5, 5. So this will be somewhere like here. And the last one is 5, 2. So somewhere here. Right? So due to this irregularity of that gap, so the size now is different. But actually the size will not be different. It will remain same. If you draw it properly with proper gap, you can see the size of both the square will remain same. So you can see that previously the square was at this location, and after performing this translation, the same square is translated from here to here. Okay. So in this way, we can perform the translation of any object. Clear? Now, in the next problem, I will discuss that how to perform the rotation for a triangle. So you have a triangle with points 0, 0, 1, 1, 5, 2. Okay. Now, as I discussed in your previous class, that the rotation always performed with respect to origin, but if you want to perform the rotation with respect to some other points, so in that case you have to perform the rotation and followed by translation. Clear? So what I am saying, if you want to perform the rotation with respect to some other points, so in that case you have to first perform the translation and then you have to rotate it. Clear? So first we will consider the first problem. That means we want to rotate about the origin. Now, if you want to rotate it about the origin, so before that, I will write down the rotation matrix and make it clear all the rotation is counterclockwise. Okay, so this rotation is counterclockwise. And why it is counter? Because the matrix we derived is for the counterclockwise. The rotation matrix we derived for the counterclockwise. If you consider the clockwise rotation, in that case you have to derive the matrix once again. So our rotation matrix is nothing but cos theta. As you know, it is cos theta minus sin theta, then 0. Then next one is sin theta cos theta 0 and 0, 0, 1. Okay, so this is our rotation matrix. Now if you want to perform the rotation, so first rotation is very simple. We have to rotate with respect to origin, and this rotation matrix is the matrix which we derived for the rotation with respect to origin. And what is my point set P? The point set, the vector for the point set is 0, 0, 1, 1, 1, 1, because second point is 1, 1, and the third one is 5, 2, 1. Okay. So what we have to do? After rotation, we will get a new set of points for the same triangle. So that new set of points will be P dashed, which we, let us say this will be x1, y1, 1, x2, y2, 1, and x3, y3, 1. So that is a new set of point. Okay. Now, so we can write P dashed is equals to R dot P. Fine. If I multiplied the rotation matrix with point matrix, we can get the P dashed. So let us find P dashed. P dashed is equals to, and here you can see we want to rotate. What is the angle? So here the theta is 45 degree. Okay. So we have to write cos 45 degree minus sin 45 degree 0, then sin 45 degree cos 45 degree 0, and then 0, 0, 1. Clear? Now next, the point P is nothing but 0, 0, 1, 1, 1, 1, and 5, 2, 1. So as you know, we have to perform the simple multiplication. So if you want to perform the simple multiplication, first we will convert this theta. So as you know that this cos 45 degrees is 1 by root 2, sin 45 degree is also 1 by root 2. So it is very simple. We will keep it as it is. So we will change the value of the matrix. We will write it, we will replace the cos 45 degree by 1 by root 2. It is minus 1 by root 2. This is 0. Again, this is 1 by root 2. 1 by root 2, 0. 0, 0, 1. And this is 0, 0, 1. 1, 1, 1. 5, 2, 1. Okay. Now, if you perform the multiplication, so you can see that the 1 by root 2 will be multiplied with 0. Then again, minus 1 by root 2 will be multiplied by 1. And 1 will be multiplied, 0 will be multiplied by 5. So ultimately, what we are getting? We are getting 0, this will be 0, then this is multiplied with this one. Sorry. So 1 by root 2 will be multiplied with 0, minus 1 by root 2 will be multiplied with 0, and this 0 will be 1. So this is nothing but minus 1 by root 2 plus 0. And the next one is same, you perform the same multiplication. I am writing it, I am not doing all the computation. This 1 by root 2, okay, this one will be 1 by root 2 minus 1 by root 2 and 0, so it will be ultimately 0. And this is 0, this 5 by root 2 minus 2 by root 2 into 0, so it will be 3 by root 2. Okay, now again this 1 by root 2 will be multiplied, again the same operation will be performed. Okay. So 1 by root 2 into 0, this one into this one, this one into this one. So if you do so, you will get this element. So all the elements are 0, so it will be 0, remain 0. I am not going to the details of the computation, you can do it. 1 by root 2, 1 by root 2, 0, so it will be 2 by root 2. If you compute it, you will get it. And second one is that this entire thing will be multiplied with this column, 5 by root 2 plus 2 by root 2, so this will be 7 by root 2, right? 7 by root 2. Now, the last one. So, you know, you will get 1. So, finally, the answer will be like this one. So, after performing the rotation operation, the answer will be minus 1 by root 2, 0, 1, 0, 2 by root 2, 1, then 3 by root 2, 7 by root 2, 1. So now if you convert it, you will get the points. So one point, what are the different point sets? The different point sets are, so after performing the rotation, the point sets will be minus 1 by root 2 comma 0. Another point is 0 comma 2 by root 2, and another point is 3 by root 2 comma 7 by root 2. Clear? So you can do your own calculation and you do it accordingly. So in this way you can rotate. So after performing the rotation of this object with respect to origin, about origin, and with the angle 45 degree, you will get those final points, and if you plot it, you will get the rotated triangle. Okay. Now next, we will perform the rotation with respect to a fixed point. So the rotation is about minus 1, 1. So whatever the rotation matrix you got, so this rotation matrix R, which is cos theta minus sin theta, that rotation matrix 0, sin theta cos theta 0, and that 0, 0, 1. So this rotation matrix which we derive, this is with respect to origin. Fine. So if you do something else, so if you want to rotate with respect to some other points, the first operation you have to perform, translate this point along with all the points of this triangle, that means this point, this one and this one. Translate everything with respect to origin. So here what we have to do, we have to translate this minus 1, 1 to the origin, and subsequently all the points will be translated accordingly. So first operation we need to perform is the translation. So before that I will write down the point matrix. The point matrix will be 0, 0, 1, 1, 1, 1, 5, 2, 1. Okay. And you know the translation matrix T will be 1, 0, Tx, 0, 1, Ty, and 0, 0, 1. Okay. So what we have to do, first we have to translate this point to the origin. Now if I want to translate this point to the origin, so what should be the Tx? The Tx should be 1 and Ty should be minus 1. Fine. So what we have to do, I have to find out the translation matrix. I got it, and with the translation value this one. Make it clear. I want to translate with respect to these 2 points. So I have to shift this -1 to the origin and 1 to the origin. That means I have to make it 0 and I have to make it 0. And how we can make it 0? By adding +1 with this value and by subtracting my 1 from this one. So that means the Tx will be 1 and Ty will be -1. Fine. And after translation, I have to apply the rotation matrix where the theta is equals to 45 degree. And after performing the translation, after performing the rotation, I have to again shift the entire things. That means the point -1, 1 and with all the points translated point of the triangle to its with original position, with respect to its original position. Fine. So to do so, what we have to do, we have to perform the reverse translation. So if you perform the reverse translation, we will write down it T inverse. So it will remain same. The translation matrix will remain same. But the factor will change. The Tx will be -1 and Ty will be +1. Okay. So finally, what we should write? So and P dashed is your final. After performing all the operation, the P dash is the final set of points. Okay, so P dash is our final set of points. So after performing all operation, what we have to do? We have to write down the. We will get the P dash equals to x1 y1 1, x2 y2 1, x3 y3 1. So after performing rotation and translation, reverse translation, all those operations, we will get that final P dash. So what we can write P dashed is equals to, P is a set of point. Fine. On this point set, first we have to apply the translation. Then I have to apply the rotation and then I have to perform the reverse translation. Okay. The sequence will be like that. On P, first we are performing this operation, then with the result we are performing this operation, then with the result we are performing this operation. Make it very clear. Don't write like that. T into R dot T inverse and then P. You are applying the transformation on the point set P. So you have to write P, and what the first operation you are doing? You are doing the translation. So P into T. Then you are doing the rotation, right? With the result, whatever we will get, we will multiply R. Then whatever the result we will get after that, with that we will perform the reverse translation. So the sequence will be like that, but the multiplication will be performed from left to right. Okay, so my final P dash will be something like that, 1 0 -1. So I am writing this T inverse 1 0 -1, 0 1, Ty is 1 and then 0 0 1. After that I have to perform the rotation, cos 45 degree 1 by root 2 minus 1 by root 2 0, and then I have to write 1 by root 2 1 by root 2 0, and then I have to write 0 0 1. Okay, and finally I have to write the value of T. And what is T? T is same 1 0. Now what is the Tx here? Tx is 1. So 1 0 1 0 1 minus 1 0 0 1. And with all, I have to perform the multiplication of the point matrix. So this will be 0 1 5. It is 0 1 2 and 1 1 1. Okay. So if you perform the entire multiplication, you will get the final result. So that is our result of the rotation with respect to a point -1 1. So here we are not rotating with respect to origin. We are rotating the entire triangle with respect to a point -1 1. So we shift the point to the origin. Subsequently, we shift the entire point of all the coordinates of the triangle with respect to origin. Then rotate it. Then perform the reverse translation. Okay, so it is clear. Now, the next problem which I will discuss. So if you solve it, you will get the answer. Okay. Now next problem which I will discuss is the scaling. Okay. So what we want to do? We want to perform the scaling operation with respect to a point 2, 2. Okay. Now, before that, what I will show you, I will perform the scaling, that is free scaling, not with respect to 2, 2. First, we will perform the free scaling. I will show you how the free scaling will be performed. Then I will show you how the scaling operation will be performed with respect to 2, 2. Because I already discussed that if you perform the free scaling, so it is your coordinate system. This is your object. And if you perform the free scaling, after performing the free scaling, the object will be shifted somewhere like here. Clear? But in case of, if you want to perform the scaling with respect to some point, fixed point, so in that case it will be not like that. So your object will be, suppose your object is this one, and if you want to scale it with respect to this point, so this point will remain fixed, it will not change its position, and the remaining points will change its position. So maybe I am scaling it in such a way that it will increase its size like that. But you see, you observe one thing, in our scaled object, one point is fixed. Okay, so that can be only performed if we this type of image you will only get if you perform the scaling with respect to a fixed point. So for this particular problem, I will show you how to perform the scaling. First, I will show you how to perform the scaling with respect free scaling, where we don't have any point. Now next I will show you that problem. Okay, so first let us write what is the scaling matrix. The scaling matrix is Sx 0 1, and this is 0 Sy 1 and 0 0 1. This is our scaling matrix. Clear? The point matrix P will be something like that. It will be 2 2 1. I'm just writing the points, and it will be 10 2 1, and the last one is 2 10 1. So if you want to perform just ordinary scaling, free scaling, so your P dash will be the resultant point set, which is x1 y1 1, x2 y2 1, and x3 y3 1. Okay. And so how we can get P dash? We can get P dash just by multiplying S into P, by doing this operation. So if I apply the value, if I substitute the value in this corresponding equation, we will get the resultant P dash. And you know what is the scaling factor? The scaling factor is 2 2. That means here Sx, that means the scaling factor along x direction is 2, and the scaling factor along y direction is also 2. Clear? So if I write it, it will be P dashed is equals to 2 0 1. I am substituting the scaling factor 0 2 1 0 0 1. I am writing it, and then we write 2 2 1 10 2 1. So if you perform the multiplication, it will be 2 2s are 4, 2 and 1. So it will be, sorry, just a minute. It is just, this matrix is little bit wrong. So it will be 0 0 1. Fine. So that's all. So it will be 2 2s are 4, 2 into 0 0, and this is 0. So it is result will be 4. Okay. Now the next one will be 2 into 10, 0 into 2, 0 into 1. So it is with 20. And this one, last one will be 2 into 2. So it will be 4. Rest are the 0, rest elements are 0. Now next one is 2 into 0, 2 2s are 4. So it will be 4. Similarly, the next one will be 4, and the next one will be 20. And in the last case, it will be 0 0 1. So this is our resultant matrix. That means after performing the scaling operation, the points of the scaled triangle is 4, 4, 20, 4 and 4, 20. So you can see there is no common points. Okay, no points are commons. All points get changed. So here the entire triangle will be shifted from its original position to somewhere else. Clear? Now, if you want to perform the scaling with respect to the point 2, 2, then how we can do that? So to perform the scaling with respect to point 2, 2, what we have to do? So we want to perform with respect to this point. So the system which is associated with this point, we have to bring the entire system to the with respect to origin. That means we basically we have to shifting our coordinate system according to that, where the origin will be treated this one. So that means I have to translate all the points with respect to origin. So if I want to translate the point 2, 2 with respect to origin, so you know that what will be our translation factor? The translation factor Tx will be -2 and the Ty will be -2. Fine. Now after that you have to perform the scaling by using this matrix 2, 0, 0, this one. And then after performing the scaling operation, you have to shift it to its original position. That means again you have to send the origin to the location 2, 2. So if you want to send 0, 0 to the point 2, 2, that means you have to perform this operation. You have to add 2 with 0. Okay. So for the translation matrix, the factors are those one, and for the reverse translation, the factors are this one. So what we have to do? First, we have to apply the translation on this point set. Okay. So we will write down the translation matrix first. So it will be 1, 0, Tx, this is -2, then 0, 1, Ty, this is again -2, and last one is 0, 0, 1. Okay. Now, so we have to apply the translation on where? With this point set. Okay. And what is the point set? 2, 2, 1, 10, 2, 1, and 2, 10, 1. After performing the translation, whatever the result you will get with this entire result, you have to perform the scaling operation. Okay. So we have to write down the scaling matrix. So our scaling matrix is nothing but 2, 0, 0, 0, 2, 0, and 0, 0, 1. After doing the scaling and all the translation, everything, every operation, so what we have to do? We have to, after doing everything, we have to perform the reverse translation. So to perform the reverse translation, what you have to do? Again with this result. So let us say this is result R1 and this is the result R2. So we have to multiply the reverse translation matrix. That is, so translation matrix is 1, 0, -2. So reverse translation matrix will be 1, 0, 2, 0, 1, 2, and 0, 0, 1. So we have to multiply the reverse translation matrix. This is T inverse with the R2. So this is our reverse translation matrix, this is our scaling matrix, and this is our translation matrix. So if you multiply all those things, so whatever you will get, that will be your result. Okay. So in this way you can perform the scaling operation with respect to fixed point. And again I am repeating, you should be very careful, because mainly the student makes the mistake. The mistake is like that, as you know the sequence, you know that I have to perform the translation first, then the rotation, and then the reverse translation. You know all those things, but what you will do practically, while you will write this thing. You will write down T first, then you will perform the rotation, then you will perform reverse translation with the points at T. So entire result will be wrong. Not like that. Be very careful while you are doing those things. So you remember the sequence. I have to perform the translation on which? Translation on this point set P. So I have to write T dot, I have to perform this operation first. After performing the translation, I have to do the rotation. So rotation or whatever scaling, whatever operation you need to perform, you make it, you perform that operation with it. Okay. Then whatever the result you will get, now you perform the reverse translation operation on it. So this sequence, the writing sequence will be this one, but while you are multiplying, your multiplying will be from left to right. Okay. So in this way, after performing the multiplication, you can get the result of the scaling object. You can get the coordinate of the scaling object, where the scaling operation is performed with respect to the point 2, 2. Okay. Now, next one is, we will perform the rotation 90 degree in counterclockwise direction. Okay. So it is very simple. If you want to perform the rotate the same object, so you want to rotate the object in the counterclockwise direction with the 90 degree. So what you have to write, you have to just use the rotation matrix. R equals to cos theta minus sin theta 1, sin theta cos theta 1, and then 0, 0, 1. So you know that theta is 90 degree. Whatever the value of theta, it may be 90, it may be 60, it may be 30. So whatever may be the angle, you put the value over here and perform the rotation. And another thing is very important, if that operations are composite, that means first you perform the scaling operation with respect to the point fixed point 2, 2, and then perform the rotation operation. Then what will be your sequence of operations? You have to find out the rotation matrix R. You have to find out the translation matrix T. You have to find out the reverse translation matrix T inverse. You have to find out the scaling matrix S and the corresponding values. And you also know the point matrix P. So, but what is your sequence of operation? This sequence of operation is very important. First, we want to perform the scaling operation on the point set P. So, we will take the point set P. We multiplied the translation matrix on it so that I can translate it to the origin. Then after doing so, I will rotate them. After performing the I have to scale it. Instead of rotation, I have to scale it. After performing the scaling operation, I have to perform the reverse translation. After performing the reverse translation, what you have to do? You have to rotate R. You consider that we are rotating, as it is not mentioned that you have to rotate with respect to any points. So consider whatever the translated point, scaled point you will get, you are rotating each and every points of the object with respect to origin. So here we don't need to perform any sort of translation or reverse translation. We just multiply the rotation matrix with it and we will get the final points at P dashed. Okay. So this is the sequence of operation, but while you are multiplying, the multiplication should be this one. Okay, in this order. Now, the next one is, here we have a line segment with the point 2, 6 and 6, 8, and we have to perform all type of reflection. Okay, so as you know that there are different types of reflection we already learned. So these reflections are reflection with respect to x-axis, about x-axis. So first type is reflection about x, reflection about y-axis. Number 3, reflection with respect to origin, that means 0, 0. And the fourth one is reflection with respect to the line y equals to x. So those are the 4 types of reflection we already learned. So we have to apply the reflection on the line segment and all the 4 types of reflection. So before performing the operation, what you have to write? You write down the reflection matrix. So let us say Rx is the reflection matrix with respect to x-axis. Fine. So while you are reflecting with respect to x-axis, what is your reflection matrix? So while you are so as I already discussed that here everything is plus plus. This is your x-axis. So here the x will remain plus, but y is minus. So nothing else. We have to, the first one will be 1 0 0. Second is 0 minus 1 0, because I am just multiplying the negative symbol minus 1 with the y value so that I get the points in this area. Now in this coordinate. Now the last one is 0 0 1. Similarly, the reflection matrix with respect to y-axis is, y-axis means I have to plot, my object is here, I have to plot it over here. So here you know that value of x is minus and y is plus. So it will be minus 1 0 0 0 1 0, and this will be 0 0 1. Okay. Now reflection with respect to origin, that means this point. So if your point is over here, it will be reflected over here. So reflection matrix with respect to origin will be, if you know everything is minus in this coordinate, so minus 1 0 0 0 minus 1 0 and 0 0 1. Okay. And the last one is the reflection with respect to y equals to x. I already discussed. So y equals to x is the some line segment like this one. So if any value, if coordinate is x comma y in this area, the same point will be reflected over here with the coordinate y comma x. So what we have to do over here? So reflection with respect to line y equals to x. So what we have to do? Here x will be replaced by y and y will be replaced by x. Okay. So it is 0 1 0 1 0 0 and 0 0 1. So all three are the three different types of reflection matrix. Okay. So what we have to do over here? We know the point matrix. What is our point matrix P? So here our point matrix is 2 6 and 6 8. So it will be 2 6 1 and 6 8 1. Okay. And we will multiply this point matrix with all the reflection matrix. So first the operation I will perform, we will find out the point set P dash if I reflect the object with respect to x-axis. Okay. So my equation will be Rx dot P. Okay. So if you perform the Rx dot P operation, what you will get? You will get equals to, Rx is this one. So you write it 1 0 0 0 minus 1 0 0 0 1. Write down it. Points matrix is 2 6 1 and 6 8 1. So if you multiplied them, what you will get? You will get the result 1 into 2, 0 into 6 and 0 into 1. So ultimately your result will be 2. Okay. Now this will be multiplied with the second column. So it will be, you can see 1 into 6. Okay. 1 into 6 and 0 into 8. So it will remain 6. Now y value. Y value means this one will be multiplied by this column. So 0 into 2 minus 1 into 6, 0 into 1. So it will be, now you can see previously it was 6 and now it becomes minus 6. Very simple. Similarly, if you multiply this one with this, it will be minus 8. Okay. And the last one is 1 1. Clear? So my reflected points will be the reflected coordinate of the reflected line segment is 2 comma 6 and second one is minus 6 comma minus 8. If I want to reflect, sorry, it is wrong. So not 2 comma 6, it will be 2 comma minus 6. This is x, this is y, and another point is 6 comma minus 8. Okay, 2 comma minus 6 and -6, -8. So first one is a reflection with respect to x-axis. So if it is our x-axis, so if the point is here, which is 2, 2, 6 and 6, 8, the same line segment will appear over here. So I'm showing you here, you can see that. So consider this is 2 and this is 8 and this is again 2 and this is 6. So first point is 2, 6. This is 2, 6. This is the first point, and second point is 6, 8. Fine. So this is 2, this is 4, this is 6. So here it will increase. This is 2, this is 4, this is 6, this is 8. So 6, 8 will be somewhere like here. So the line segment is this one. Okay. Now if you reflect it, so this is -2, -4, -6, -8. So my reflected point is 2. This is 2, -6. Okay. So 2 -6 is this one. And this last one is the 6, -8 is this one. So you can see the reflected line segment will be like this. Okay. If you draw it properly, you will get more accurate image. So this is about the reflection with respect to x-axis. Okay. Now, next we will show you the reflection, how to compute the reflection with respect to y-axis. So we will write reflection with respect to y-axis, and you know the matrix. So I am not writing the matrix once again. You know it. So it is not required to write it. I'm just writing the equations. Fine. So here you know that the point set after performing the reflection is P dash is equals to reflection matrix with respect to y-axis into P. Okay? And you know the reflection matrix with respect to y-axis is -1, 0, 0, 0, 1, 0, 0, 0, 1. And the point set is 2, 6, 1, 6, 8, 1. So if you multiply them, you will, so it will be -2, okay, and -6, 6, 8, and 1, 1. -2, -6, 6, 8, 1, 1. So if you plot it, you also can see that this is your, if it is y and this is x, and 2, 6 and 6, 8, the line segment will be somewhere there, and after reflection you will get the image like this one. Now we want to reflect with respect to origin. Fine. So my point set P dashed will be RO dot P. And what is the origin of RO? RO, in the RO we have to perform, we have to make x and y both negative. So it is x, this one -1, 0, 0, 0, -1, 0, and 0, 0, 1. Okay. And this is 2, 6, 1, 6, 8, 1. So if you multiply them, you get everything will be negative. So -2, -6, -6, -8, 1, 1. Okay. So if your line segment is this one, so it will be reflected over here. Okay. And this is for RO, this is for RY. Now, the last one, we want to reflect with respect to the line y equals to x. So the reflection matrix R equal R y x dot P. Okay. And in this, what is the matrix for R y x? X is replaced by y and y will be replaced by x. So it will be 0, 1, 0, and it is 1, 0, 0, and this is 0, 0, 1. Okay. And the point set is 2, 6, 1, 6, 8, 1. And if you multiplied it, you can see that 0 into 2, 1 into 6, 0 into 1. So 6 will be over here, 8 will be over here, 2 will come over here, 6 will come over here, and this is 1, 1. Okay. So what actually happened? So if this is the line segments. If this line segment is y equals to x, so if you reflect it, it will be reflected over here. So this is our line segment L, and this is the line. This is the line. Just a minute, let me draw it more clearly. So consider this is the line. Okay, so this line is y equals to x. This is our another line, and this is our line. Okay, so here this line segment, equation of this line segment is y equals to x, and this is our original line segment with the point set P. Okay, original line segment L. Now after reflection with respect to y equals to say x, the line segment will be displayed over here with the points at P dash, and let us say the line segment is L dashed. Fine. So this is, in this way you can perform the reflection. So you know, if you know the RO or all type of reflection matrix, then you can reflect any object with respect to any axis. Clear? Now, and there is a last one. The last one is the shear. Okay. So consider that you have the square with the vertices 0, 0, 0, 2, 2, 0 and 2, 2, and you have to perform the shearing with respect to x direction and with respect to y direction. Fine. So you know, if you want to perform the shearing with respect to x direction, that means Sx is the shearing matrix. Better to write, instead of Sx we will write T of Sx. Fine. So we will write it T of Sx, shearing transformation for the shearing with respect to x axis. So as you know, what is the shearing matrix? The shearing matrix is 1, shearing factor SHX 0, 0, 1, 0 and 0, 0, 1. Okay. And similarly, the transformation matrix, the shearing transformation matrix for shearing along y direction, that means T of Sy will be something like that. It is 1, 0, 0. It will be SHY, shearing factor for y direction 1, 0, 0 and 0, 0, 1. Okay. You know the point set. The point set is 0, 0, 1, 0, 2, 1, 2, 0, 1 and 2, 2, 1. Okay. So if you want to perform the shearing with respect to x direction, the shearing value is given. So that means shearing factor with respect to x direction is 2 unit. So you replace this 1 by 2. You get the TSX, which is nothing but 1, 0, 0, 2, 1, 0 and 0, 0, 1. Okay, and if you multiply it, the point matrix with the shearing matrix, so what you will get? You will get the sheared, coordinate of the sheared object. That means your new P dash will be T of Sx dot P. Okay, so if you multiply it, you will get it. So it is very simple. It will be 1, 0, 0, 2, 1, 0, 0, 0, 1, and then write down it 0, 0, 1, 0, 2, 1, 2, 0, 1 and 2, 2, 1. And if you multiply it, you will get the answer. Okay. So similarly, I am showing you how to perform the shearing with respect to y-axis. So it is given that the shear factor SHY is 2 unit. It is given. Shear factor is 2 unit. So what we have to do? We have to write down the shearing matrix. So we will write it like 1, 0, 0. We just replace this SHY by 2. 2, 1, 0, 0, 0, 1. So how you will get the points at P dashed? So to get the point P set P dash, you have to write TSH dot P. So that means that, which implies that 1, 2, 0, 0, 1, 0, 0, 0, 1 and 0, 0, 1, 0, 2, 1, 2, 0, 1 and 2, 2, 1. Okay. So if you multiply them, you will get the answer. So in this way, it is very simple. Two concepts are there. The transformation which needs to be performed with respect to origin, if that transformation needs to be performed with respect to some other point, simple concept, translate it first to the origin, do the performation and then send back. And if the operation where we don't need to perform any translation, just multiply the matrix with your point set. Now the important consideration is that you have to, while you want to implement this everything in terms of the code, you have to take the input of the points, and after taking the inputs, you have to multiply the inputs with the matrix. So here you need to know, you must write the code for matrix multiplication. If you don't write the code for the matrix multiplication, you cannot write the program for it. So you have to know very well that how to handle the matrix, how to write down the code for matrix multiplication, how to take the input to the matrix. So you have to know all those things, then you can easily implement all the operation in terms of a program, and then you can incorporate it in any applications. Okay, so that's all about the today's lecture, and thank you for watching my video.